All right, I would consider this video, I'm going to call this a fun experiment just to see what we can do with area models. So we're going to take a general quadratic here and see if we can solve this quadratic generally by following the process of the completing the square that I've shown in a previous video. So the first thing we would recognize in this is that I want to factor an a out of this thing. So I'm going to rewrite this as an a times x squared plus b over ax, and we'll leave the plus c on the outside there. Okay, this is following the pattern that we've established in previous videos. And so now for the stuff that is inside this set of parentheses, I want to build a square. My square is clearly going to have an x squared there. These two pieces on the diagonal have to add up to b over ax, but they need to be split equally between these two parts. So that would give me a b over 2a, half of b over ax, and a b over 2ax here as well. So filling in dimensions on the box or on the square means that's an x and that's an x, and this must be a plus b over 2a, and this is a plus b over 2a, and that forces this part in here to be b squared over 4a squared. But up here, consistently here, this part was a 0, so these two pieces together have to add up to be 0, so this must be a minus b squared over 4a squared there. So if we write that part, so what it looks like for this is the area of the square is x plus b over 2a squared, and I have the add-on part of minus b squared over 4a squared. Of course, all of that is inside of this a plus c, like that. So a little bit more space here. We'll distribute the a through, and we'll get an a times x plus b over 2a squared minus b squared over 4a plus c. And so if we find common denominator out on that part, we get a times x plus b over 2a squared minus b squared plus 4ac all over 4a out there. And this is the completed square version of that. And so now, when we are doing the quadratic formula, what we actually want is to set this thing equal to 0 and solve. I'm going to make an arrow diagram for this, because that's who I am. I'm going to add a b over 2a onto that. That then is going to get squared. Then I'm going to do a times all of that, and then add on this negative b squared plus 4ac over 4a. And that's supposed to get me to a 0. If I build my inverse areas or arrows coming back, I need to subtract all of what I have up there. So if I subtract a b squared minus, or a negative b squared minus 4ac, I'm going to get a b squared, positive b squared, because I'm subtracting that, minus 4ac over 4a. I will then divide by a, so I'm going to have times 1 over a. And this will be a plus or minus square root, and this will subtract b over 2a from it. So starting with b0, I'm going to add b squared minus 4ac over 4a. So 0 plus that is just b squared minus 4ac over 4a. I'm going to multiply that whole thing by 1 over a, which will give me b squared minus 4ac over 4a squared. We take the plus or minus square root of that is going to give me plus or minus square root of b squared minus 4ac all over, well, square root of 4 is 2, and the square root of a squared is a. And then finally, I'm going to subtract b over 2a from that, okay, or add negative b over 2a. So that becomes a negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And I see that those already have a common denominator, so I can add the numerators of negative b plus or minus the square root of b squared minus 4ac all over 2a. And now in my arrow diagram, if I look back up at that, I've arrived back here at the x. So this is x, and there is my quadratic formula. Pretty slick.